Engineering students, are you struggling in your soil-based calculations? Worry no more, because CalcuLUPA is here. It is a soil-based calculator programmed using Python language.
To start the calculator, run this Python language program in any programming site or application. After that, a short description about CalcuLUPA will be displayed and the calculator will ask for your name. For example, "Hello, Miss Mathis, what would you like to calculate today?" Then, a list of formulas and choices will be displayed asking you to pick one.
If you choose number 1, you'll proceed to the soil bearing capacity calculation. The calculator will ask you to enter several values. First, input effective cohesion in kilopascals. Let's use 35. Then, enter the bearing capacity factor, which we'll set to 30. After that, input the unit weight of soil in kilonewtons per cubic meter. Let's use 18. Enter the depth of foundation in meters, which we'll set to 3. Next, input the bearing capacity factor for unit weight. Let's use 45. Followed by the foundation width in meters that is set to 1. Then, enter the bearing capacity factor for shape. Let's set that to 15. The calculator will then display the ultimate bearing capacity in kilopascals. If you choose number 2, you'll go to the settlement calculation. The calculator will prompt you to enter several values. First, input the applied pressure in kilopascals. Let's use 50. Then, input the footing width in meters. Let's try 1.5. Next, enter Poisson's ratio. Let's use 0.3. After that, input the modulus of elasticity in kilopascals, which we will set to 100,000. And finally, enter the influence factor, which we'll set to 1.5. The calculator will then display the immediate settlement in millimeters.
If you enter number 3, you will be redirected to the dry density calculation. The program will display the formula and ask you to enter values. First is the mass of dry soil in grams. Now, let's try to put 1,500 grams. Then, it will ask you to enter the volume of soil sample in cubic centimeter. Let's try to put 1,200. The calculator will show you the result of computed dry density, which is 1.25 grams per cubic centimeter, with the interpretation below. If you enter number 4, you will be redirected to the soil moisture content calculation. The program will display the formula and ask you to enter values. First is the weight of soil well wet in grams. Now, let's try to put 800 grams. Then, it will ask you to enter the weight of soil after dried in grams also. Let's try to put 650. The calculator will show you the result of computed soil moisture content percentage, which is 23.08%, with an interpretation below.
If you enter number 5, you will be redirected to the compacted volume calculation. The calculator will ask you to enter the loose volume of the soil. For example, if you enter 2.5 cubic meters, it will then ask for the compacted volume, which represents how much the soil volume decreases after compaction. Let's try using a compaction factor of 1.2. After entering the values, the calculator will show you the results, which is 2.08 cubic meters. This means the compacted volume of the soil is 2.08 cubic meters, which is smaller than the loose volume of 2.5 cubic meters due to the reduction of air voids. The compaction factor indicates how much volume reduction occurs when the soil is compacted. If you enter number 6, you will be redirected to the shrinkage factor calculation. The calculator will ask you to enter the excavated volume of the soil. For instance, if you enter 3 cubic meters, it will then ask for the compacted volume, which is the volume after compaction. Let's try entering a compacted volume of 2.5 cubic meters. The calculator will show you the result, which is a shrinkage factor of 16.67.
And if you enter number 7, you will be redirected to the bulk density calculation. The calculator will ask you to enter the soil's weight in grams. Here, let's try to put 200 grams. Then it will also ask you to enter the total volume in cubic centimeter. Let's try to put 250. The calculator will show you the result, which is 0.80 gram per cubic centimeter, with an interpretation below. And if you enter number 8, you will be redirected to the particle density calculation. It will then ask you to enter the soil's weight in grams. Let's try entering 300. Next, it will prompt you to enter the soil solid's volume in cubic centimeter. Let's try entering 120. The calculator will then display the result, 2.50 grams per cubic centimeter.
If you enter number 9, you'll be taken to the porosity calculator. The program will first display the formula used. It will then ask you to input the bulk density and the particle density, both in grams per cubic centimeter. For example, if you enter 1.3 for bulk density and 2.65 for particle density, the calculator will return a porosity value of about 50.94%. After that, it will display a short explanation to help you understand what this percentage means. If you enter number 10, you'll go to the soil permeability calculator. The program will first display the formula used. The calculator will then ask for the permeability coefficient, the cross-sectional area, the head difference, and the length of the flow path, all in centimeters or squared centimeters. For instance, entering 0.02 for K, 100 for A, 50 for delta H, and 25 for L
will give you a result of 4 cubic centimeter per second.
After that, a short interpretation will help you understand whether the soil has low or high permeability.
And if you choose number 11, the program will proceed to the store a value section. The calculator will ask how many values you want to store. For example, enter 2. It will then prompt you to name each formula value, for instance, bulk density for the first one, and input its numeric value, say 1.2. For the second, you might enter moisture content, and then put a value like 0.25. After entering all values, the calculator will confirm the values have been stored successfully and display them in a list format.
Option 12 lets users view formulas for various soil calculations. It prompts the user to choose a formula, then displays the equation along with descriptions of the variables involved. For example, selecting bearing capacity shows Terzaghis formula, while settlement calculation shows the settlement equation. It's a quick reference for understanding the formulas.
And lastly, if you enter number 13, your total number of calculation in the session will be displayed, along with the ending statement exiting CalcuLUPA. Thank you.